Testing. All right, C++, we are going to look at page 100, example 3, problem number 11, employee class. That starts at the bottom of page 100. Create a class called employee. So we'll have to create a class object file, employee.h, that includes 3 pieces of information as data members: a first name of type string, a last name of type string, and a monthly salary of type int. Your class should have a constructor that initializes the 3 data members. Provide a set and get function for each data member. If the monthly salary is not positive, set it to 0. Write a test program, which will be our employee test.cpp. We're going to write source code that will interact with the class object header file. So it has to have the same class name, employee, and we're testing it. Employee test.cpp program that demonstrates class employee's capabilities. Create 2 employee objects and display each object's yearly salary. And then give each employee a 10% raise and display each employee's new yearly salary amount again. Well, let's look at the development of our UML. In the top compartment, we have the account name, which will be employee. In the middle compartment, we have the data members. And we've decided on variable names. They will be private to this class object employee. So private, we use the hyphen. First name is going to be string data. Last name is going to be string. And monthly salary is going to be an integer amount. Now, remember, we're dealing with salary. We'll be talking about real numbers with decimal points as we continue the course. So for now, we're dealing with integers. The bottom compartment, we want to identify our constructor with the less than, and the greater than. The employee object must be the constructor name. They must match. And objects begin with an uppercase. Your constructor begins with an uppercase. And then convention syntax for the UML just varies a little bit from our actual C++ syntax. The first name is going to be string, the last name is going to be string, and the salary is going to be an integer. We have our public, so we use plus. Member functions, set first name, open paren, and we're going to have a name identifier of type string. We have a public get first name that receives nothing but returns a string to the calling environment, which is our driver program. We have a set last name, which expects to be passed a string identifier and assigned to name. We have a public get last name that does not receive anything from the calling environment, but returns a string value to the calling environment. We have a set get name monthly salary method that expects to have an integer passed to it from the calling environment, and we'll assign it to salary. And we have a public get monthly salary, which doesn't receive anything from the calling environment, but returns an integer value to the calling environment. Now, if you're starting this from scratch, you kind of want to design this as part of your development process. Starts getting your logic working and kind of have a visual or a graphic of what transpires in the employee class object. And then as we begin to create or instantiate class objects, we will name the first class object employee 1, and employee objects carry their data members throughout their lifetime. So when we access employee, we're able to reference the private data members: first name's current value, last name's current value, and monthly salary current value. When we reference employee 2 class object of type employee, where employee 2 carries its data members throughout its lifetime. So it knows its own first name, its own last name, and its own current monthly salary. And we could have employee object instantiated number 3 and 4 and so on. And each employee object knows its own data members throughout its lifetime. So I hope that helps visualize as we're working with abstract object-oriented programming in Chapter 3. And the best thing I can say is that as you work with object-oriented programming and class objects, you become better with time. So in this course, you're introduced to object-oriented programming in Chapter 3, and we return to it in a more advanced course. But I'd like to walk through the development then of a new program with you, with the development of our employee class object. So a new project. And we're going to name this exercise Chapter 3, number 11. And we will place it in Chapter 3. Yes. Okay, I guess I've created it, so I'll open that project from my first name folder, Chapter 3, and I have exercise 311. And there's my Visual C++ project. Okay, so I have my example 3_11 driver program, the C++ source code, and I've added the employee.h header file in the header files category. I want to make sure that we set our project properties for C++ precompiled headers, not using, that's okay. So in my driver program, what is it that I want to do? I want to create 2 employee objects, so I'll need 2 constructors. Of course, you need to include your employee.h. Our very own header has to exist within the header file subdirectory, and we have to write that code, and we include it using the double quotes. I want to create 2 employee objects, so I have an employee header file, which I'm going to write that source code for. I'm calling the instructor. I'm going to instantiate a new employee 1 object of type class employee. I'm going to initialize with the braces a first string value, a second string value, and a last integer value. We are to instantiate 2 employee objects, so employee 2 is of type employee, a class object. I'm going to initialize with this constructor a first string, a last string, and a starting integer balance. We want to display each employee's yearly balance, so I'll have a prompt employees yearly salaries to the screen. And then I'm going to retrieve, but notice there's no new line there. So I'm still in the same line of output on my screen. Retrieve and display employee one's monthly salary. Now, monthly salary is a data member of employee one, and employee one knows its own data members. It always knows its own data members' values. So I have int month salary. I'm looking at employee one that get monthly salary. I'm going to get the current monthly salary from employee one object, and I'm going to send that to monthly salary. Monthly salary one is equal to employee one that get monthly salary. So int monthly salary one is initialized to employee one that get monthly salary. We're going to get that salary and see out employee one that first name, add some space to our output, employee one that get last name, so we'll print the last name, colon, $sign, and the monthly salary one, which we were able to retrieve, and multiply it by 12, so we get the annual income. And do the same for employee two. Give each employee a 10% raise. Employee one that set monthly salary, we want to change the current monthly salary by the monthly salary one plus monthly salary one divided by 10, that'd be 10%. So we're going to give a new assignment to employee salary one and employee set monthly salary two with a calculation, monthly salary two plus monthly salary two divided by 10. And then we display each salary again with or after the 10% raise. Our employee.h should look closely like how we developed our UML for the employee class object. Class employee, open brace, and find its closed brace, colon, sure enough. I like to look at my private data because it's the top middle compartment, I guess, in the UML, and I have my first name of type string, my last name of type string, and monthly salary of type int initialized to 0. In the public area, we have our constructor expecting to receive a string and assign first, a string passed from the calling environment to assign last, and an integer value passed and assigned salary. We're going to assign and initialize first name of our current object, data method, or data member, and assign last name, the value of last that was passed to the constructor. And before we assign salary, we're going to check if salary, the value passed from the calling environment, is greater than or equal to 0. If it is, then monthly salary as our monthly salary data member was initialized to 0. It will be, if greater than 0, assigned to salary, the passed value from the calling environment. We have our set first name, our get first name, set last name, and get first name as public member functions. And then set monthly salary. If it's not positive, set it back to 0. So we have a void, it's not going to return anything to the calling environment. Set monthly salary, we're going to receive the salary amount from the calling environment. And if salary is greater than or equal to 0, we're testing for validity, then our monthly salary data member can be assigned to that salary value. Otherwise, it will remain at 0. If salary is less than 0, is negative, then we'll set monthly salary back to 0. Return monthly salary with a get monthly salary that will return the monthly salary, which is the current value of monthly salary in this object's monthly salary data member. Okay, let's save all and Control F5. We have Lisa Roberts. So employee number 1, Lisa Roberts for first and last name, and her income is $4,500 times 12 for $54,000. And employee 2 is an employee object, and we initialized employee 2's data members as first name Mark, last name Jean, and an integer value of 4,000 was passed. It is greater than 0. It's validity checked, and we take that times 12 and get 48,000 for an annual income. And then we wanted to calculate new salaries after a 10% raise. So the new annual salaries after the 10% raise, and you can check to see if that's correct. 59,400 and 52,800. We're adding 10% of each of their annual incomes to their previous salary. So I will share the driver program, the example 03_11.cpp. And I'll share the employee.h. All right. Thank you very much.